Muted.
Hi, everyone. We're going to wait a few minutes for everyone to join us. Please hold on. Well, great. Thank you all for joining us. I know that people will join us, but I want to be cognizant of your time. I'm Kathy Dello. I'm with the Climate Impact Research Consortium at Oregon State University. I'm also with the State Climate Office in Oregon, and I'm one of the collaborators on the Pacific Northwest DEWS, or Drought Early Warning System. So welcome. If this is your first time or you've been joining us for these bi-monthly webinars, we're happy to have you. What we've been doing as a part of the Pacific Northwest Drought Early Warning System is having regular updates on drought and climate, even when there isn't drought in the Pacific Northwest. So that's why we're gathered here today, and we have a great slate of panelists who will be speaking to you. And normally I would have a few collaborators from NIDIS on the call with me helping me run things, but they are busy today. So it's me flying solo, and I have some support from the Northwest Climate Hub as well. So for the agenda, I'm just going to give you an intro to NIDIS and the Northwest DEWS, and then you get to hear from me again because it's my turn in the rotation to talk about the climate recap. We'll move on to Troy Lindquist from the Weather Service in Boise, who will give us an outlook for the next few months and probably talk a little bit about La Niña. Steve Parrott with the Oregon Water Resources Department is going to talk about a program that Oregon's undertaking to do place-based water planning around the state. We'll get a quick USDA Climate Hub update from Holly Prendeville. And then Joel Sankey from the USGS is going to talk to us about something that's definitely fresh in our minds here in the Northwest, about climate and wildfire and erosion ensemble and how it foretells more sediment in Western USA watersheds. And I think he's prepared to talk a little bit about the Eagle Creek fire, although I'll let him weigh in on that. So what is the National Integrated Drought Information System, or NIDIS? What it's meant to do is provide a better understanding of how drought impacts us as a society. And the Drought Information System is a network of drought early warning systems around the country, and you can see the map on the right. The Pacific Northwest DEWS is one of the newest ones. We launched it in February 2016 after going around the region and listening to stakeholder feedback. The goal is to fill in that entire map. You may not think of some of those places that are blank as being drought prone, but they actually are. So what it's meant to do is improve accessibility of information, manage drought better, drought early warning. Some people think that sounds like a siren, but it's really getting out ahead of these disasters. So these regional drought early warning systems, of which we are in the Pacific Northwest, we work directly with on-the-ground stakeholders. Each DEWS has its own flavor, driven by regional needs and capacities, and we were very fortunate to have a really big turnout to our February meeting in 2016. Got a lot of feedback about where the gaps are. We've been working with the state drought coordinators in Washington, Oregon, Idaho, and Montana. We've been putting on webinars like these, and we host in-person meetings as well. Certainly, we would love to hear feedback from any of you about what we're missing, what we could do better, research that we could undertake. Really, this is a system driven by the stakeholders who live here in the Northwest. I've already alluded to this. We launched the DEWS in February 2016 in Portland, and the strategic plan is now final and available on drought.gov. But it's a living document, so go ahead and take a look, and like I said, provide us any feedback. What it really is a roadmap for going forward with the Northwest DEWS, the activities that we want to undertake, the meetings that we want to have, and the people we want to connect with. So it has a 2-year time frame, so it went into action about a month ago, and we're going to follow it closely. Some of the big priority areas that we heard is that we need to improve monitoring in some areas, including snowmelt areas. We need to do better at drought planning and mitigation, and we thought maybe we could combine forces as states to better utilize our capacity. So just a few events that are coming up. We do these in-person meetings. One is next week in Olympia, and we're co-hosting this with the Climate Impacts Group and the Washington Department of Ecology. And then on November 2nd, we'll be in Boise with a suite of partners that you see listed there. So please register, it's free, but we need to have snacks and materials for you. We aren't broadcasting the meetings. Anybody who's tried to live cast an in-person meeting knows that technical difficulties run rampant. So please join us in person, but we'll have the presentations on drought.gov afterward. And like I said, we've been doing these webinar series bi-monthly. So then we've been doing it on every 4th Monday, which turns out to be Christmas in December. So we've bumped it up to December 18th. So if you have this showing up in your calendars automatically, make sure to take note of that date and time. And again, please register. Helps us know that you're here. And we'll talk about whatever's relevant at that time. That's the great thing about these webinars. Now with that, normally we would turn it over to the next speaker, but I am the next speaker. We rotate the climate recaps around the region, and it turned out to be Oregon's turn this time. So what I'm going to do is just show a few figures from the 2017 water year in the Pacific Northwest. If you lived here, it's no surprise to you that it was a wacky year indeed. So the thing that jumps out first and foremost to me is the fire activity in the Northwest this year. We thought with such a great snowpack, such a wet winter, you know, maybe we'd make it through the summer okay, but we dried out pretty rapidly, and we'll talk about that in a few upcoming slides. But we had large fires burning across much of the region, up and down the Cascade Spline, down in southwestern Oregon. The Chetco Bar Fire was the largest fire in the country at one point, and smoke all over the region, as you can see across Idaho, the interior of Washington, and in Oregon. So the air quality was terrible for those of us who spent the past summer here. But since this is a drought webinar, I wanted to move to the drought monitor and see where we're at, do a check-in. So given all the fire activity and the super dry summer that we had, you may think that this map may look a little bit more intense. Our longer term deficits are still there, but aren't super large. If you look into Montana, they've experienced some pretty dire drought conditions. But across the region, we have pockets of D1 moderate drought, some abnormally dry across Oregon, Idaho, and the rest of Washington. And then some areas that we call D-Nada. We're not really seeing any sort of signal. The Willamette Valley is one of them, even though it was dry here this summer. The recent rains have really helped us out. So if we go just look at the water year as a whole, the mean temperature in the Pacific Northwest, we see that it was largely above normal across the region. This is from the West-Wide Drought Tracker. It's one of my favorite sites to look at some of these pictures. And except for the interior of Washington and north central Oregon, it was largely a warmer than normal water year. And if we look at the same picture for precipitation, again, this is no surprise to those of us who've lived here. It was a wet water year, and some of the dark green areas in Idaho, Southwest Oregon, and up in Washington were the record wettest water year. But there's always more to the story than looking at just 12 months. So let's peek under the hood. If we go back to summer, this was one of the hotter summers on record here. We had a cool start to the year, but we warmed up and dried out really quickly. So it was the record warmest summer across much of southern Oregon, eastern Oregon, parts of Idaho, and even that area in interior Washington was still above normal, and on the Olympic Peninsula as well. And in terms of precipitation, we went from a super wet start to the year and wet start to the water year, where we got almost an entire water year's worth of precipitation in the first few months. We dried out in the summer. So these hot and dry conditions really primed us for the wildfires that we had. We started to talk about flash drought, which sounds buzzy, but really it's when you switch from these super wet conditions to dry ones pretty rapidly. But going back to winter, for those of us who live in the Northwest, we're used to cool and wet, but this was cold and snowy. So December through February, the temperatures were below normal and much below normal in the areas that like to trap cold air, like the Willamette Valley. And when you trap the cold air and bring in precipitation, which we always get in the summer, you have a recipe for low elevation snow and ice. So a bunch of school children in Portland got a bunch of days off. Those of us here in Corvallis had a few icy commutes to work. And basically, this primed the mountains for some great snowpack accumulation. And I just changed the time period here, but from October to May, the beginning of the water year, it was again wetter than normal. That spot up there near Pendleton, I think, is bad data because it doesn't make any sort of physical sense. So it's good to recognize the limitations of your products when just generating these outputs. I wanted to jump back to October of last year just to remind you of how horrendously wet it was. Here in Corvallis, we got a foot of rain, which smashed the record by 3 inches. And we don't smash monthly records by 3 inches. So while it's been wet for the past week or so, it's nothing like we saw last year. So we really got off to a racing start for a water year. And I just covered that again, that bad data showing up in North Central Oregon. And just looking at the calendar year to start, average temperatures have jumped to back above average after the cool start to the year. The Northwest and that northern tier are definitely some of the cooler, hotter states, but all the states in the US are above average for the calendar year. And with precipitation, it's been a wet start to the calendar year, even with those dry summer months. Summers are dry here in the Northwest, and we understand that, but it was noticeably dry. So I'm not going to take any more of your time. These are the sources for the maps. The slides will be posted online. And now I am going to turn it over to Troy Lindquist. Troy, are you on?
Yes, can you hear me okay?
Yeah, great. So Troy Lindquist is the senior hydrologist at the National Weather Service in Boise, Idaho. And he's really been along with us for this DEWS ride, even before we were a DEWS. And he's a great partner, and we'll learn a lot from him today. So Troy, take it over.
All right, thank you so much, Kathy. Okay, just a quick overview. We'll start off just looking at what's in store for the next couple of weeks, and then we're going to take a look at the latest ENSO information from the Climate Prediction Center. And we'll do that first before we get into the long-range outlook, since the ENSO is a major player in those outlooks that the Climate Prediction Center sends out. So just the near-term weather situation, just wanted to give a broad picture of what's going on over the North Pacific. And this is water vapor imagery in the upper levels of the atmosphere, the yellow lines, the general weather pattern. You can really see it buckled across the North Pacific, and over the West Coast, the Eastern Pacific, you see that kind of building ridge over the area. And that is going to be our main large-scale weather maker for the Pacific Northwest for the next several days. And typically this time of year when we see that ridge building, it tends to lead to drier conditions, so below normal precipitation, and temperatures can be pretty seasonal, although this time of year we need to start watching out for stronger inversions, and particularly for valley locations, as it's harder to warm up once those inversions really get strong. So this is the precipitation forecast total for the next 7 days. So it takes us through this week and through next weekend, and you can see really light amounts. Perhaps a quarter inch to maybe some few locations up to a half inch over the Cascades of western Washington and towards the west coast, and some light precipitation amounts over central Idaho and the Panhandle region, but for the most part, a pretty dry weather pattern expected for the next several days. And temperatures, this is the high forecast for today, pretty seasonal, 62 in Boise, 61 in Seattle, and pretty much normal temperatures are forecast for today as far as maximum temperatures go. And we'll just step out a few days, and this is the high temperature forecast for Thursday. Again, under that ridge, pretty stable conditions. Probably see a little bit cooler air sliding south out of Canada east of the divide, but over the northwest it should be pretty nice and about normal. And this takes us all the way into next weekend. This is for Sunday, about a week away, and again, not a whole lot of change as far as high temperatures go. So what about early November? Beyond this next week, this is the model projection, and there's pretty good consensus along the models that we're going to see our jet stream kind of being shut into the north of the Pacific Northwest, and we're going to maintain some form of that ridge over the Eastern Pacific and the Northwest. So again, it doesn't look like a whole lot of change, and this would favor drier than normal conditions. And we'll look at CPC's 8 to 14 day outlook for early November, or late October, early November, and it does indeed show a dry signal over the Pacific Northwest, particularly over Washington and kind of the northwest half of Oregon. And the chart on the left is for the temperature outlook for that period, and then slightly favors above normal temperatures for the entire Pacific Northwest region. So the latest ENSO status from the Climate Prediction Center. There's a La Niña watch, continues to be in effect across the equatorial region of the Pacific. And again, it's not a sure thing when it's a watch, but conditions are certainly leaning toward that direction. So ENSO neutral conditions are present. But again, as I just said, that looks like things are favoring a move towards at least a weak La Niña. Equatorial sea surface temperatures are near normal or below normal across the central and eastern Pacific, and thus with the conditions pointing towards a La Niña, there's a 55 to 65% chance that we will see a La Niña ENSO phase as we move through the fall into the winter time period. So let's look at the supporting graphics. Here are the sea surface temperatures over about the last 4 weeks. And you can see the cool colors, the blues, those are the negative anomalies or below normal anomalies over the equatorial regions of the Pacific. And you can see stronger across the eastern Pacific, and that gets a little bit less as you move towards the date line at 180 degrees there. And anomalies are actually above normal over the western Pacific Ocean. So now that we looked at the plan view, I like to look at the cross-section views and look at some of the ocean temperature anomalies at depth. And you can see the graph on the right. We'll start the top one from late August. You can see the negative temperature anomalies below the surface. And as we move to the second, third, and fourth graphs on your way down, that just moves us all the way down to October 10th. So pretty close to the present, you can see those negative temperature anomalies have actually expanded across the central and eastern Pacific. So again, pointing towards developing La Niña when you look at both the sea surface temperatures and then those temperatures anomalies at depth. So our mid-October plume of model ENSO predictions are all in pretty good agreement. If you, it's where they think we're going to go with this ENSO phase. So if you look at the left side of this graph, the September time frame there across the time across the bottom x-axis, you can see the black dot. That's the observed conditions. Then as you move right with the model plumes, are all in pretty good agreement that we're either going to maintain about where we're at or even see those negative temperature anomalies increase. So the model plumes definitely favor moving towards at least a weak La Nina phase here over the next few months. So the official probabilistic ENSO forecast, we'll look at the bar graphs and the time periods across the x-axis along the bottom. They're in 3-month chunks of time. The far left one is September, October, November. And as we just move in those 3-month blocks of time to the right, you can see the DJF, that's December, January, February, our core winter months. You can see the probabilities of La Nina developing actually increase. So generally a 55 to 65% probability that we'll see La Nina developing from the fall months into the winter months. And then as we move into the latter parts of winter through the March, April, May, into the springtime, and finally into the early summer months, on the far right of the graph, you can see a trend towards neutral conditions in the ENSO phase. So now we've seen all that, let's take a look at the typical wintertime La Nina pattern. And most of us have probably seen this graph many a times over the years when La Nina conditions are expected. We typically see cooler than normal temperatures from southeast Alaska, stretching down into the northern plains, and then back across the northern Rockies and most of the Pacific Northwest. And then we see wetter than normal conditions quite often over the Northwest as well. So we'll look at the temperature anomalies during all La Nina episodes from prior to 1985 and then after 1985. These are composites, so just kind of putting all those La Nina years together and what the anomalies actually were. So you can see prior to 1985 on the left, you can see pretty strong anomaly for cooler than normal temperatures across the northern states, particularly northern plains, across a lot of Montana, and pretty strong still across much of the Pacific Northwest. If you shift to the right graph, you can see that signal for cooler than normal temperatures has really been washed out since 1985. So very interesting to compare the two graphs there. And we can do the same for precipitation. Prior to 1985, you can see those anomalies showing up much stronger on the left side prior to 1985. And again, we see that washed out some with episodes after 1985 on the right. So moving into the actual outlooks from Climate Prediction Center, here is the month of November. So you can see this favors below normal temperatures across southern Idaho. Otherwise, we're looking at pretty much equal chances for the Pacific Northwest as far as our temperatures go for the month of November. On the left, I just want to remind everybody to look at these in terms of probabilities. So the pie chart on the top, this is centered at Idaho Falls. Just wanted to highlight how, even though it's in the brown that favors above normal temperatures, it's just a very slight lean in the probabilities for above normal temperatures. So there's still a fairly good chance that we'll see either normal or below normal temperatures based on this probability graph that we're looking at. And the same can be shown for the precipitation. Again, for Idaho Falls, 35% probability that we'll see above normal precipitation, but also not too far off chance that we'll see normal or below normal precipitation as well. So just a reminder to look at these and think of probabilities when you're looking at these outlook graphics. So for the core winter months, December, January, February, you can see our temperatures on the left. You can definitely see a flavor of La Nina showing up in this graphic here with the probabilities favoring below normal temperatures for much of the Northwest and across the northern tier states. And shifting to precipitation across the right, you can see probabilities favoring above normal precipitation for northern Rockies and western Montana. Interesting that these probabilities are at equal chances for a good chunk of the Northwest. And I think there's some climate change signal showing up in the developing of this particular graphic here. So interesting to note that. And we'll move out in time looking at the temperature outlook for the top row is March, April, May, all the way through May, June, July. So our spring months into early summer. And you can see as we move out of that La Niña phase into a neutral ENSO condition, we're looking at either equal chances or above normal temperatures being favored. And the bottom row is our summer months into the early fall months of next year, and you can see above normal temperatures favored through that entire time period. And we'll look at the precipitation probabilities for that same time period again for next spring, early summer across the top, equal chances for precipitation categories. And as we move through next summer into early fall on the bottom row, we see equal chances pretty much everywhere except for the Northeast United States. And that is the end of my presentation.
Great. Thank you so much, Troy. I learned a lot, as always, and it seems like maybe we as skiers and snowboarders shouldn't get too excited about a La Niña right now, but the chance is up in the air. So Steve Parrott is with the Oregon Water Resources Department, and the way that these webinars work is that we at CERC invite a special guest, and the USDA Climate Hub in the Northwest invites a special guest to each webinar. So Steve is a CERC special guest this year. Steve, you should have control now, but I've met the Oregon Water Resources Department staff who are working on the place-based planning effort for future water security a few months ago, and I thought this would be a great update for the webinar. Steve, are you? There you are. Steve, I will turn it over to you.
Steve is here?
Yes.
Okay, can everyone see that?
Yes.
All right. Well, thank you, Kathy, for inviting me, and my best wishes to everyone today. My contact information is on this front screen here, so if anyone has questions or wants to get a hold of me, you can do it there. Oregon's place-based integrated water resource planning is a direct result of the statewide integrated water resource strategy that came out in 2012. So that strategy is, maybe everyone's familiar, but that is a blueprint for helping Oregon address its water needs into the future. And it made a number of recommended actions that could help result in that, one of which was place-based or local water resource planning. And after the strategy came out, they decided to develop a set of draft guidelines that would help the local communities do this sort of planning. And those came out in 2015. And then we got authorization from the state legislature to actually do grant making and be in the business of supporting these local communities. I won't read all these, but there was a set of principles developed to guide this planning effort at the community scale, and those are listed here. One thing is it's really intended to be a locally initiated and led collaborative process with the state as a partner. Back in the 60s, 70s, and 80s, the state did some planning effort, but that was largely the state planning with a little bit of local input. This is really intended to be a local state partnership, so a little bit different setup. The draft guidelines laid out 5 planning steps. The first is to build this collaborative and inclusive process and develop a governance agreement for how the group would make decisions and organize itself. and to ensure that there was a broad spectrum of water interests at the table. The second step is really about understanding the water resources of the planning area, sort of looking at the supply and all the factors that affect supply. Step 3 is about understanding the water needs or demands, both in stream and out of stream, and looking at current needs as well as future water needs. We asked the groups to look 50 years into the future, so that's a pretty distant vision. The fourth step is developing or identifying a set of integrated solutions to meet those needs. So the full spectrum of solutions from conservation to all the way to possibly new storage and everything in between. And the fifth step is wrapping all that up into an integrated water resource plan that identifies data gaps, it identifies needs for feasibility studies, perhaps, and when possible, identifies projects that everyone agrees can and should be implemented. Before we started, we wanted to understand where we were going, so we set these objectives, and they're largely qualitative objectives to test out those draft planning guidelines and see what works and what doesn't work. Inspire collaboration and integration, gain experience to help inform the next iterations of the statewide integrated water resource strategy, build local capacity for this type of community-based water planning. Complete 2 plans by 2019 was the goal, and we wanted to leverage funding. As I'll get into that more here in a minute. So with our $750,000 that we got from the legislature, we went through a solicitation process to gauge interest in doing this type of planning. And my colleague Harmony was the only planning coordinator at that time. She did a fair bit of outreach in a short time frame, talked to a lot of people around the state, and that resulted in 16 letters of interest or applications essentially for grant money. And we had $750,000 available, and we awarded $657,000 in grants and kept a little bit in reserve. And 1 year later, we did a survey of all of those people who submitted letters of interest, the 16, and the interest in this sort of community-based planning, place-based planning remains very high as the result of our survey. So here are the 4 planning areas that we selected, and they are quite different in terms of geography, their water issues, the culture, the circumstances, the water issues that they're facing. So they were quite diverse in the way they're organized as well in terms of the structure of the project teams. And we purposely selected a diversity of planning groups, and we thought we would learn more in that way through this pilot phase of the program. So you can see there's 3 that are on the east side of the state where it's quite dry, and 1 on the mid coast. And I guess everyone here is familiar with sort of the water of Oregon being wet in the western portion. So the planning groups, I just thought I'd briefly touch on who is involved in these planning groups. They were intentionally set up to be quite diverse, to have all of the water interests at the table. So you can see here the different types of groups or different types of people that are involved, and I may have missed a few, but I think the outcome, the best outcome from the first year of the program has really been that we've had all these folks sitting at a table, working together, talking together, understanding each other's concerns and interests around water, and having good open dialogue and sharing of information. So that's been good, and I think we're building. The communities are building some trust amongst the different water interest groups. Oregon Water Resources Department in this program plays 4 separate roles, really, from program coordination. We're a planning partner, meaning we're at the table with these planning groups, helping them. We provide technical assistance and coordinate technical assistance. And we, of course, provide financial assistance in the form of grants. So we have 4 different roles. One thing we've done under program coordination was to organize sort of a mini conference in Bend in May of this year, where we brought a delegation from each of the 4 planning groups to the event, really to share their experiences to that point with each other, get to know each other, provide some feedback to the department in terms of how the program was working for them, and get some feedback how they thought we could make improvements from our end. And I think that sort of building camaraderie between this pilot phase cohort of planning groups was really valuable, and they seemed to enjoy it. We got a lot of good feedback from the event. We did a post-event survey, and 100% of the people who completed the survey said they would like to do a similar event again, where they could all get together. And we have a similar event. We're just starting planning a similar event for the spring of 2018. The department, as I said, has provided financial assistance. We were granted $750,000 from the Oregon legislature for this effort. And just focusing on the larger pie chart to the left there, I just want to make the point that it quickly has become a private or a public-private partnership in terms of funding this work. The partner contributions are, some of it's in the form of cash and paid staff. A lot of it's the donated time of people that are participating in the planning effort. But we've also secured some private funding from foundations and others, and there's a big chunk of private foundation funding that's pending right now to help a couple of the groups. So the department is getting a big leverage on our investment. We recommended to the groups that they provide a 25% match to the grants that we were making, and so far that match has been over 50%. The pie chart down to the right there is just how the money was divided up between the 4 planning groups and the reserve, the $93,000 of reserve funds. Technical assistance has proven to be a big lift in this effort, as complex as water is, and the science and the policy and the law. We have to help these communities develop a shared understanding of the water situation, and they have of course a broad diversity of their level of understanding, all the way from technical experts to a citizen who has never talked about water. So we have to sort of build up their knowledge base, and we are relying upon the help of a number of agencies, as you can see here, and we appreciate the help of everyone who has been giving us technical assistance. It will continue to be a challenge for us moving forward. And that's the end of my presentation.
Great, thank you so much, Steve. And we're really happy to be a partner on this project. And it's also very DEWS-esque. It's very in the spirit of what we're doing here. So I'm going to turn it over to Holly Prendeville. She is actually I'm running her slides. She is the coordinator of the Northwest Climate Hub. And I will let her introduce herself as I pull up the slides.
Excellent. Hello, everyone. I'm the coordinator of the Northwest Climate Hub. Within the USDA, there are 10 regional climate hubs, and the Northwest serves Alaska, Oregon, Idaho, and Washington. Montana, you are served by the Northern Plains Climate Hub. And today I just wanted to highlight that we have been spending the last 2 years on revamping the websites across the USDA. And so what you'll see is the new Northwest Climate Hub's website. And if there's information from the old website that you're having a challenge finding, please let me know. My email address is in the upper left-hand corner. And if you want to get to the original site, if you go to the upper right-hand corner of the site, you can see it says original site. So you can get back to that information and it is accessible. But do let me know if there's something there you're using and can't find so I can help direct you to that information, or potentially I did not put it in there and so need to do so. But here you can see our new site. It's mobile friendly and hopefully more user accessible, user friendly for you. And if there's information you would like showcased or feel like something's missing, again, please reach out and let me know. And for the Northern Plains, I can connect you with the folks there for Montana. Next slide, please, Kathy. Today, our special speaker is Joel Sankey. He's with the USGS. He's a research geologist, and he's going to be talking to us about his recent work that was published in Geophysical Research Letters, being Climate, Wildfire, and Erosion Ensemble foretells more sediment in Western USA watersheds. And with that, I'd like to turn it over to Joel. Thank you, everyone.
Hello, everyone. This is Joel. Thanks for the introduction, Holly. And can you all see my slide okay at this point, my screen?
Yep, we got it.
Okay, great. Yeah, so I'm Joel Sankey, and I'm a research geologist with the USGS. I live down in Flagstaff, Arizona, and I'm going to talk to you about this work that we recently published using an ensemble model to make projections of watershed sediment yield as a function of future wildfire for all of the watersheds of the Western USA. And I will talk just a little bit about the Eagle Creek fire and kind of put it into context of that as well. So my collaborators on this project include scientists from the USGS like me, scientists from the Forest Service, and then several different universities. Okay, so the area burned by wildfires has increased in recent decades, and it's expected to increase in the future for a lot of watersheds worldwide due to climate change. And burned areas within watersheds increase soil erosion rates, which can increase downstream accumulation of sediment in rivers and reservoirs. And then increased sediment can dramatically and often pretty negatively impact aquatic ecosystems, decrease water quality and supply, and increase the cost of water delivery to people. So this is just one example here on this slide of a global assessment of watershed vulnerability to wildfire from a paper published about a year ago. And this particular index here in this paper that you're seeing in this map here is derived from a qualitative geographic overview of several important drivers of wildfire impacts on watersheds. But the work that I'll show you today is an attempt to try to more quantitatively model future wildfire impacts on watersheds, specifically in the West. And we focus on the Western US in our own work, you know, because we work and we live here, but we also know that wildfires are expected to increase across the region in coming decades due to climate change. And we're also focused on the West because a lot of the watersheds with projected increases in wildfire are important headwaters of rivers and reservoirs that meet the water demands of people and communities across the West or across the region. One statistic that always catches my eye is that 65% of the water supply in the West originates from forested watersheds that are prone to wildfire. And so it follows that a lot of the water supply in the West is potentially vulnerable to any future increases in wildfire. So the work that I'm going to show you that we've done and published recently is done at a really large geographic extent and very large watershed scale. But it's really, you know, fundamentally driven by the fact that so many individual towns and cities and communities across the region have actually already started to act on concerns about watershed vulnerability to future fire. And in particular, a lot of communities are concerned that increased wildfire potential due to climate change could couple with forest conditions that in many places are, you know, potentially primed for large or potentially catastrophic wildfires, which in turn can increase flooding and sedimentation and negatively impact watersheds and water supply to people that rely on those watersheds for a big range of ecosystem and, you know, economic services. So I know a lot of you are located in the Northwest, and I actually grew up in Portland. And I know that Portland's drinking water comes from the Bull Run watershed, which was threatened by the Eagle Creek fire this summer. The fire burned inside the Bull Run watershed management unit, but ultimately not inside the Bull Run watershed. But protecting the watershed was a huge priority during the fire, as I understand it. And the concern specifically was that rains following a fire within the watershed could cause erosion that would bring high volumes of sediment into the source water. Okay, so a lot of this work that I'm going to show you and talk about hinges on the fact that, as one of my colleagues eloquently says, fire does stuff to soil. And that stuff can make water run off faster and in larger volumes after rainstorms. And that stuff can also make soil erode faster and in larger volumes due to rainfall and runoff processes. And then sediment that erodes from hill slopes can ultimately end up in channels and streams and reservoirs faster and in larger volumes than would otherwise occur without fire. This is a helpful conceptual overview made by Joe Wagenbrenner, who's a research scientist with the Forest Service that studies these kinds of processes. And it shows the state changes in processes that can cause increased runoff and erosion after moderate or high severity fires. So as we walk through this, just remember that the ovals represent a change in state and the rectangles represent the resulting change in process. So fires can combust vegetation, obviously, which can result in a loss of plant canopy. It can also burn the soil surface, which can do things like enhance soil water repellency of the soil surface, or a loss of ground cover of the soil surface, or a loss of soil organic matter. Loss of plant canopy, loss of ground cover can reduce interception and transpiration of water or rainfall. A loss of ground cover can reduce roughness, sort of like very fine scale microtopographic roughness of the soil surface, which can increase the velocity of fluids like water flowing across the surface. Loss of ground cover can increase sealing, like a physical sealing or physical chemical sealing of the soil surface. We can have increases in rain splash effects or forces and increased soil erodibility with loss of soil organic matter. A lot of those things together can increase runoff, as I've said, of water across the soil surface. And that then combined with some of these changes in soil erodibility can increase soil erosion. And ultimately then what we can end up with, and one of the big concerns with post-fire water runoff and soil erosion, is that it can make our streams and rivers and reservoirs look like this one in this photo, which is, generally speaking, not good, in particular for water quality, among other things. So as Holly said, we just about a month ago published this paper and wrapped up this study that we did. Climate, wildfire, and erosion ensemble foretells more sediment in Western USA watersheds. And so now for the remainder of the talk, I'm going to present just a synopsis, kind of the methods and key results from this paper for you guys. So the background and premise for this study, as I've said, kind of with my opening slides, is that the area burned annually by wildfires has increased in recent decades, and it's expected to increase in the future due to climate change for much of the Western U.S. And burned areas within watersheds increase soil erosion rates, which can increase sedimentation in downstream rivers and reservoirs. Increased sediment can dramatically and often negatively impact aquatic ecosystems and decrease water quality and supply for people. But at least prior to this study, which watersheds will be impacted by future wildfires was largely unknown. And so the objective of the study was to try to answer the question of how will post-fire sedimentation change in Western U.S. watersheds as a function of future fire. The methods that we used in the study involved combining an ensemble, or essentially just a combination of numbers 1, 2, and 3 in this slide here to make future estimates of number 4. So we combined predictions of future wildfire due to climate change and predictions of increased soil erosion due to wildfire to make projections of watershed sediment yield due to future fire. And the reality is that this was mostly a data synthesis project because future wildfire projections had already been published by the USGS based on several future climate scenarios. And there was at least one set of Western US-wide predictions of post-fire soil erosion that had been published prior to our project as well by co-authors that I have listed on my talk today in the title slide. So we combined or synthesized these different data sets to make predictions about future fire and sedimentation in watersheds across the West. Because that particular piece of bringing those together and making these quantitative predictions hadn't been done yet. So the fundamental data that went into the ensemble projections of future post-fire watershed sediment yield are shown in these maps here. And we use projections of future fire and burned area summarized by decade and by very large Hungate watersheds. And there are 471 of these Hungate watersheds that we specifically analyzed out of the major forested watersheds you can see in this area mapped in panel C of this slide. And we looked specifically from the decade of 2001-2010 through the middle of this century, the decade of 2041 to 2050. And the fire projections are based on 3 different climate change scenarios, and then we used estimates of watershed scale sediment yield due to post-fire erosion from something called the GeoWet model. And so these here are the maps of the key results from our study. D, the panel D in this slide, shows the mean % change in annual Hungate watershed post-fire sediment yield from that first decade of the century to the middle decade of the century. And then that panel E shows the mean absolute change in annual Hungate watershed post-fire sediment yield from the beginning of the century to the middle of the century, those 2 decades. And then panel F shows the statistical significance of the mean % change. So the statistical significance of the changes we're showing you in panel D in this figure. We summarize the data as we are showing here, as I'm showing you here in panel D, to try to reduce the projections into kind of simple and meaningful results by calculating a relative % change in post-fire sediment yield from that decade of 2000 to the decade of 2040. So in D, post-fire sedimentation is projected, just to kind of boil down the results even more and give you the really short synopsis or summary of results across that entire mapped area in panel D. Post-fire sedimentation is projected to increase by 10% for nearly 9/10 of the western US watersheds by the mid-21st century. And then also in D, post-fire sedimentation is projected to increase by more than 100%, or a doubling, for more than 1/3 of watersheds by the mid-21st century. And as I said, E simply shows here the absolute value of the change in sedimentation in megagrams of sediment per watershed. And then F shows the statistical significance. And in F, the changes are statistically significant for more than 8/10 of the watersheds in the West. But we also specifically identified 37 watersheds, which are these ones shown in this kind of light gray color here, for which the increases are especially robust and certain, we say, with respect to the range of natural variability in climate and fire and erosion. So because I mentioned the Eagle Creek Fire and the Bull Run watershed at the beginning of the talk, I wanted to highlight the large Hungate watershed that contains the fire and then Bull Run sub-watershed. So that large Hungate watershed is one of the watersheds where we project more than a doubling, more than 100% increase in post-fire sedimentation due to increases in fires by mid-century. And it's also one of those 37 watersheds I mentioned in light gray in the statistical significance map over here, for which the increases are especially significant or robust and certain with respect to the range of natural variability in climate, fire, and erosion. So, I think we'd say based on these projections that the fact that a large fire burned near the boundary of Bull Run this summer and sparked concerns about impacts to water quality might not be a one-off, but instead could be something we might see more of in coming decades. One other point I was going to make here is that Eagle Creek Fire was human-caused, and human activity certainly influences when and where wildfire ignitions occur, and models for fire projections that we used accounted for that. But climate and weather conditions remain the dominant drivers controlling wildfire behavior and spread. And so while humans may increase ignitions in the future, changes in climate and weather are what determine whether or not those ignitions grow into large fires. Okay, so that's really the end of what I wanted to show you. This is just the summary of kind of the key results from our study. It's the first research we know of to use an ensemble of climate, fire, and erosion models to project variability and post-fire sediment yield at a watershed scale as a function of future wildfire conditions across the West. We project a 10% increase in post-fire sedimentation for nearly 9/10 of watersheds, and then project a doubling or more than 100% increase for more than 1/3 of watersheds. And then, as I said, a lot of those watersheds with projected increases in fire and sedimentation are important surface water supply for downstream human communities. And I'll just show you, just to finish up, this is the paper if any of you are interested in looking it up. And then we also published our data through the USGS for this study, and those are available for download from the USGS. And that is the end of my talk.
Great, thank you so much, Joel. That was really, really interesting. And I just wanted to note that these webinars take the flavor of whatever's happening and whatever's on our minds. So that was certainly relevant to those of us here in the Northwest. So we have a few minutes for questions. I know we're bumping up on lunch in Pacific time, and if you're on Mountain time, hopefully you ate while watching this. Feel free to enter it in the chat box or the question box, and our presenters can take it. And they all offered their contact info, so I think they're willing to answer questions offline as well.
Kathy, this is
and
Talia. Just wanted to highlight to everyone that the URL for the Climate Hubs is in the chat box as well. Thank you.
Great, thanks. And I just wanted to remind everybody that we'll be in person next week in Olympia and Boise. It'll be very similar to what you heard today, but a lot longer. So we hope to see you there. While we're waiting to see if questions come in, I wanted to once again thank our panelists. They put time into these presentations, and it's always really interesting and really helpful. And the DEWS is really leveraging the capacity of our state and federal and local partners. So we couldn't do it without them. And a special thank you to Gabrielle Roche-McNally and Holly Prendeville from the USDA Climate Hub, who help out with these things, and were certainly a great source of support on this one when I was flying solo. Do we have any questions?
I have a question for Joel.
Okay.
My question for Joel is, I just noticed that some of the watersheds, neighboring watersheds, had extremes. Either they were going to stay more or less the same, whereas others could have a dramatic amount of change. Do you have a general sense of what the properties are, the differences between those watersheds that can allow one to stay relatively normal and another to have extreme change?
Yeah, so some of it is just that we did the work at those Hungate watersheds are very large. And so I think part of it is that because those watersheds are so large, and because we ultimately did all the modeling work but then summarized it at that very large watershed scale, there are some of them that have more forest than others, some of them that are more mountainous than others. And some of them that have probably a much wider variability in, say, terrain and topography than others. So I think sometimes that's why you do see some of these sort of side-by-side, somewhat different looking projected results in large watersheds that are side-by-side.
Thank you.
Okay, well, hearing no more questions, thanks again to our speakers. Thank you to the participants. We will be back online doing a webinar on December 18th. Join our mailing list on drought.gov if you're not on it, and we will alert you to that webinar. Everybody have a great Monday. Thank you.